Hello dear aspirants, this is Dr. Saurabh Sir's class. Our contact number is 98367930076. Again I am repeating it. It is 98367930076 and our email ID is saurabhsirclasses@gmail.com. Please feel free to call us or drop a email in our email ID so we can organize one-on-one sessions and regular, and you can join our regular batches, so that will be beneficial for you for preparation of the examinations like TIFR GS, NBHM, ISI, CMI, etc. So please feel free to contact via these contact details. Okay, so now we are going to solve a problem which is given in our TIFR GS 2025. So the question is telling us that given any linear transformation T from R square to R square, there exists linear transformation T1 and T2 which is from R square to R square such that 1 comma 0 belongs to the kernel of T1 and 0 1 belongs to the image of T2. Then our T equals to T1 plus T2. So this is an true and false question. So we have to conclude about this by the perfect logic of truth of this given statement. Okay, so what can be done? So now we are going to decompose T. So the problem asks us to decompose T into two components, which are what? Which are my T1 and T2. That means and they told us that 1 comma 0 is belonging to our kernel of T1 and so we can say that our T equal of 1 comma 0 is equals to 0 and 0 comma 1 is being in my image of T2. So our T2 of B equals to 0 1 for some V which is in R square. Okay, and they have told us to T equals to this. So now we are going to analyze the conditions. So our for T1 the vector 1 comma 0 must map to 0. Then this implies that T1 xy can be defined in such a way that our T1 of 1 comma 0 is equals to 0 while it can act arbitrarily on the rest of R square. Okay, so now we are going to see the condition on T2. So for T2 the image must contain our 0 1. This is written in here. Okay, 0 1 must contain our image. So now this implies that there exists some V belongs to R square such that T2 of V is equal to 0 1. So the rest of T2 can be defined arbitrarily as long as the condition is satisfied. So now we are going to combining T1 and T2. Since our T1 equals to T1 plus T2, we can distribute the action of T on R square between RT2 and T1 and T2 in such way that the above conditions are satisfied. So now we are going to construct our T1 and T2. Okay, so let our T of 1 comma 0 equals to V1 and T of 0 comma 1 equals to V2, where our V1 and V2 is lying in our R square. So now are the images of 1 comma 0 and 0 comma 1 under T. So now we are going to define T1 as T1 of x comma y is equals to y into V1. Since this ensures that our T1 comma 1 comma 0, T1 of 1 comma 0 is equals to 0 since our y is 0 for 1 comma 0. Okay. Now we are going to define T2 as our T2 of xy is equals to T of xy minus T1 of xy. This ensures that our T2 of 0 1 is equals to T of 0 1 minus T1 of 0 1. that will be what? That will be V2 minus 0. As we wrote that our T of 0, 1 is equal to V2, so we are using it. V2 minus 0, it will be V2. That means our T2 of 0, 1 is equals to V2, sorry, since our V2 is equals to 0, 1 lies on the image of T2. So the second condition is satisfied. So clearly T equals to T1 plus T2 by construction. Okay, so we can say that the final conclusion of the statement is the decomposition exists, so the statement is true. So the given statement that we can decompose, so the decomposition will exist and our statement will be true. So again, I am telling that please feel free to contact via these contact details, so you can enjoy all the services of Dr. Saurabh sir's classes, and you will rock in your examinations. Okay, so thank you guys.